Now we've done most of the easy parts, getting a paddle and a ball up and running on our screen, the next few parts are going to be a little bit more tricky. And the first thing we're going to tackle is how to detect collision when the ball hits the wall at the top and the bottom and getting the ball to bounce. Now, we only need to detect collision on the top and the bottom walls, because when the ball hits the right or the left edges of the program, it should actually be caught by one of the paddles. And if it isn't, then that means that player has missed the ball and it's a point to the other side. So we need to focus on how can we detect when the ball has collided with the top or bottom walls. When has its position gone past a certain point that it probably is going to collide with the wall? We've done something similar in Snake, but it's again time to revisit this topic. Now, on top of that, we have to figure out how do we get the ball to actually bounce? And what does bouncing actually mean in terms of changing the position of the ball? When the ball is constantly going up in the y value and going up in the x value in order to travel in this direction, what actually happens to the x and y values when it bounces? Which one gets reduced and which one stays constant? Have a think about those questions and play around with some of those numbers and see if you can complete this challenge by yourself. If you get stuck or if you just want to check the answer, then come back and I'll go through the solution with you. All right, so it's going to be inside our while loop where I'm going to be detecting the collision with the wall. And in order to detect the collision with the wall, essentially what I'm going to say is that if this screen is 600 by 800, when the ball is at a y position that is above 300, remember 300 is half of 600 and the y-axis goes from 0 to 300 and 0 to minus 300. So once the ball is past 300, then it's going to be way past the wall, right? So at that point, I can be pretty sure that it's going to hit the wall or it has already hit the wall. So that will be my criteria for detecting collision. So I can say if the ball.yCore is greater than 300, well, in that case, it's basically gone too far up and it's hit the top wall. Now, in addition, I can add a OR statement to say if the ball.yCore is less than minus 300, then that means it's gone too far down and it's hit the bottom wall. So in this case, it needs to bounce. So we need to figure out how to get our ball to bounce. And we're going to create a bounce method in our ball class in order to tell it how to do this. Firstly, we're going to need to figure out a new y, because the y coordinate needs to essentially reverse. So whereas previously our y coordinate was going up and up and up, increasing each time, when it hits the wall, it needs to reverse direction. So if it was increasing, it needs to decrease. If it was decreasing, it needs to increase. So basically, we need the opposite of what it currently is. To do that, the easiest way is to create an attribute, which I'm going to call xMove, and another, which I'm going to call yMove. These are going to start out at 10, and every time we move our ball, we're going to say self.xCore plus self.xMove and plus self.yMove. This basically hasn't changed anything. It's just that every single time the ball moves, it's going to increase in the x coordinate by 10 pixels and also increase by 10 pixels in the y coordinate. Now, when we bounce, however, we need to change our y move so that it's the opposite in terms of direction of what it used to be. So if it used to be plus 10, we want it to be now minus 10. And if it used to be minus 10, we want it to be now plus 10. To do that, all we need to do is multiply it by minus 1. So that means if y move is currently equals to 10 and 10 is being added to the y coordinate, then this ball is moving upwards. But when we reverse the direction by multiplying it by -1, now that is now -10. So we're now adding -10 to the y coordinate, which is the same as subtracting 10. So this is some basic high school maths that's going to get our Pong program to start moving in the right direction. Now back in the main.py, under these conditions, when the ball has hit the top or the bottom, we're going to get the ball to bounce. And now if I hit run, you should see that when the ball hits the top screen, it comes right back, exactly in the way that we wanted to. But the only thing that we might need to tweak is look at how far it's gone before it actually bounces. It's completely disappeared off the screen before it actually makes a bounce. So we can adjust these values accordingly. So I think it works best when we actually have it as 280. So remember that the width of the ball is 20 pixels. So if we're 20 pixels away from the wall, then that's pretty much where we need to bounce. So if I run this again, you can see that the ball hits close to the wall and then it comes right back. So this will take a little bit of thinking to get your head around it. The best way to really understand this is to print out the values of the new y and also of the y move, and also after you've modified the move in the bounce. Look at those numbers and you'll eventually be able to understand what's actually happening to the position of the ball. But effectively, all that we're doing is we're defining an amount that the ball is going to move by in the x and the y axis. We're adding that amount to the x and y coordinate in order to move the ball. And when the ball needs to bounce off the top and bottom walls, we reverse the y move number so that we get it to subtract instead of add. And that moves it in the opposite direction.